So one of the biggest challenges in section 11.9 is that a lot of the instincts you learned earlier in algebra, they're not going to apply properly here. For example, if you look at an inequality like this, and you imagine what you used to do back when you were dealing with equations, you might think that you can break this up into two separate pieces, two separate inequalities like this. That's what you would have done with an equal sign back when you were working with quadratics in Algebra 1, but unfortunately this doesn't actually lead to a correct answer. First of all, it leads you down to two inequalities like this, which, if you graph them on the number line, one of them looks like this, the other looks like this. How are you supposed to combine them? Is this a situation where you use both of them and you start from -7 and increase upward? Are you supposed to only take the place where they both overlap and start from 2 and go upward? Whichever one of those you pick, it turns out that you're wrong. For example, if you check your answer by plugging in something over here on the far left where it seems for sure it can't possibly work, try like say x equals -10. If you go back into that original inequality and plug in -10, you end up with -3 times -12, which is +36, and that is indeed bigger than or equal to 0. That actually does work. So trying to deal with these problems the way you would deal with an equation, it's just doomed to failure. It cannot possibly work. So please, if you find yourself treating these like they say equals, stop. You're going down the wrong path. That is not how you're supposed to do them. So instead, let's talk about the correct techniques. So there are two different techniques you can use to solve a problem like this. The first technique is something called sign diagrams. And it works something like this. You start with a number line, and you individually consider each separate factor in the problem. So we're going to consider x plus 7 by itself, and then separately we're going to consider x minus 2. And we're going to think about what happens when you plug numbers into x plus 7. Well, right at -7, if you plug that in, you would get a 0. If you plugged in something bigger than -7, like -6 or -5, you end up getting a positive result. And in a sign diagram, all you keep track of is positive. You don't worry about the specific details. If you plug in something less than -7, like -8 or -9, x plus 7 will come out negative. Do a similar diagram for x minus 2. At 2, it comes out exactly 0. If you plug in something bigger than 2, it comes out positive. If you plug in something less than 2, it comes out negative. And that's the sign diagram you would have for x minus 2. So then you put these two together, and you realize you are multiplying the results together. So all you really have to do now is remember your elementary school rules. If you're plugging in something below -7, you're doing a negative times a negative. And if you do a negative times a negative, your result comes out positive. Right at -7, you would have 0 times something, so it would come out 0. Between -7 and 2, you would have a positive number times a negative number, which elementary school rules, that comes out negative. Right at 2, you'd have something times 0, the result comes out 0. And for anything bigger than 2, you would be getting a positive number times a positive number, which would come out positive. Based on this diagram, we should be able to tell where the result comes out bigger than or equal to 0. It comes out bigger than or equal to 0 here, and it also comes out to be bigger than or equal to 0 over here. So the final result, if you put your answer in interval notation, which is usually what's expected, is that we've got the stuff from -infinity to -7, and then the stuff from 2 to +infinity, which is not what we were ever going to get treating these like you would normally treat an equation. Breaking them up into two inequalities was never going to produce this result for us. Now, some people don't like these sign diagrams. They feel that they're too abstract, that they require too much generalized thinking about what happens if you plug in all sorts of numbers all at the same time. So there is an alternative. This alternative technique is called test points, and in order to do test points, you also need to have the problem set up the same way we had the previous problem set up. So the first step, and this really applies to any problem ever, the first step is to get 0 on one side of the equation, and then factor. So the initial parts of this problem would look like this, to make it look kind of like the previous problem. Then you draw a number line, just like in the previous problem, but you don't bother doing the whole sign diagram thing. You don't break out each individual factor one at a time. The only thing you keep track of is those key zeros that we were encountering on the previous technique. Here, if you plug in 1, or if you plug in 3, one of these two factors will come out to be 0, and if one of the two factors is 0, it doesn't really matter what the other one is. The product is going to come out to be 0. So what we know is, right at 1, you get an answer of 0. Right at 3, you get an answer of 0. But in between and on the left and on the right, we don't really know what the results are. So what you do then is you pick some number in each region, and you just test to see what the results come out to be. So you pick some region, or some number in this region, you pick some number in this region, you pick some number in this region, and you see what the results are. Do the results come out positive, or do they come out negative? Now, which number you pick doesn't really matter as long as it's in between. Like over in here, below 1, you could pick 0 or -1 or -2 or -3 or -7,000. It doesn't really matter. Any number that's below 1 would be a good one to test over here. So I'm going to use 0 because 0 tends to be pretty easy to deal with. In between 1 and 3, the only really easy number that's in there is 2, but you could use 1.5 or 2.7 or anything at all between 1 and 3. It doesn't have to be a nice whole number like 2. And then over here on the right, you could pick anything bigger than 3. So just to kind of make the point that you could pick anything you want, I'm going to use 100. Just because it's possible. We could do that. What you do then is you plug those numbers in to this inequality, and you see what the results are. So if I plug in 0, I'm getting 0 minus 3 times 0 minus 1. In other words, -3 times -1. And the only thing I really care about is it comes out negative. I mean, it comes out positive. Oops. Negative times negative comes out positive. In here, we would be doing 2 minus 3 times 2 minus 1. So in other words, that's -1 times +1. And I suspect, with just a little bit of practice, you'll be doing this arithmetic in your head. You don't have to write it out. It's almost always really simple. Especially this last one here. When I plug in 100, 100 minus 3 times 100 minus 1 is some positive number times some positive number, so I know the result comes out positive, even though I don't need to worry about the actual fiddly little details. It's 97 times 99. What's 97 times 9? It doesn't matter. The important part that matters is it comes out positive. At the end, we do the same thing we did with the sign diagram stuff. We ask ourselves, which parts of what we've just done satisfy the inequality? We are looking for where things are less than or equal to 0. So that's in here. And that also includes these numbers as well. So make sure you include 1 and 3. So your final solution here, the overall answer, would be including 1 and 3, the numbers from 1 to 3. Now, some people don't even like this one. They don't like the sign diagrams technique. They don't like the test points technique because the plugging in numbers business bothers them a bit. There is a third alternative. Now, this third alternative is not necessarily great, but it is an alternative, and for some people, this technique just clicks for them. They just love it. So what you can do as an alternative, if you don't like sign diagrams and you don't like test points, is you could draw a graph. And here's what I mean by that. draw a graph of the function we're talking about here, x squared minus 5x minus 6. Now, if you don't know why I'm drawing a function, hold on for a second. You'll see why in just a moment. So what do we know about this function? Well, let's see. It's a parabola because of x squared. It's an upward pointing parabola. If I wanted to find out where the x-intercepts are, I would go through some steps like this. I would say, where does the function come out to be 0? That's a quadratic equation, and luckily, a fairly easy to factor quadratic equation. So we would find out that the x-intercepts are at -1 and +6. Okay, well, if these are my x-intercepts, and if this is a parabola, and if it's an upward pointing parabola, then the picture looks kinda sorta like this. I know that's not a great picture. It's kind of sloppy. It doesn't really have the right curve for a parabola, but it's mostly right. It's got the right x-intercepts. It's pointing up. Maybe I haven't drawn the vertex very nicely, but it doesn't matter. Even a relatively sloppy picture can work for us as long as we know where the x-intercepts are. So if you're looking at that picture, compare that picture to this inequality we've got over here. We want to know where that green graph is above, greater than, above or equal to 0. So, in other words, we are looking for this part here and that part there, this part here and that part there. This stuff in between, in here in the middle, this part is below 0. It's not above it. So, for our answer, the final result from this, what we're going to write up is going to be the stuff here on the left, so -infinity to -1, including the -1, and then the stuff from 6 to +infinity. The stuff in the middle, between -1 and 6, it's not larger than or equal to 0 there. It's less than 0. So you have 3 techniques you can pick from here. You can use the sign diagrams technique, you can use the test points technique, or you could do this graphing technique. If you don't like graphing, then you should probably pick either sign diagrams or test points. If you're really fond of graphing, this third technique will probably be your favorite.